3 pi halves, comma, 0. It was an x-intercept. Okay. Any questions? Okay, let's look at the last one. Okay, I wrote a little note on here. I realize these can be frustrating. These can take a while to kind of get the hang of. It does take a lot of practice. It takes somebody, David was talking earlier, he used a whole page of paper to do one problem. It's not uncommon, okay? It's just the way it is. If it makes you feel any better, I've done problems that take 5 pages of paper, okay? And then I still get it wrong. So that's not comforting, but okay, there you go. Okay, this is a pretty challenging problem. This is on your assignment. Okay, so I'd like to get through as much of this as we possibly can. This is challenging for a lot of reasons. Okay, the calculus on this can be kind of tough. Even figuring out what the domain is can be kind of tough. So let's talk about this piece right here. The x doesn't have any domain issues. The problem is what's underneath the square root. So the square root of x squared plus 1, or x squared plus x, you've got to make sure that that is greater than or equal to 0. So this is a problem that you learn how to do in 1010 and 1050. The way I like to solve this is I'd factor this and say that has to be greater than or equal to 0. And then I recognize that this is a parabola. Crosses at 0 and 1 and it opens up. The only way this can be greater than or equal to 0 is if this parabola is above or on the x-axis. So that means over here from negative infinity to 0, and then starting up again at 1 and going to infinity. Doing okay? Okay, round brackets around the infinities. What about the 0 and the 1? It can be equal to those. Okay? Okay, let's do intercepts. I'll do this in the right order this time. Let's plug in a 0. What do you get out? You get out a 0. So that means it goes through the origin. Oh, let's see. Oh, you're right. I need to back up here. I made a mistake here. What is it? Should be -1, right? That makes you feel better, right? Yeah. Okay, how's that?
What if you didn't just automatically know what that graph looked like?
You could make a sign line here, and you could say it equals 0 at 0, and I'll get this right this time, at -1, and then you could plug in numbers to see on what intervals it's positive and where it's negative. Okay. Graphically, it's a lot easier. Okay. And when does this equal 0? Remember how to solve that? When does square root of x squared plus 1 minus x, when does it equal 0? Here's what you'd be stuck doing. You'd have to move this over to the other side. You're solving a radical equation at that point. Square both sides. X squared equals x squared plus x. Luckily, this is an easy one to solve. Those go away, so I get 0 equals x. So it only has one x-intercept. It happens to be at the origin. It's at the point we just found. Okay, so this only touches the axes in one place, and that's at the origin. Okay, we at least know we've got one point on this graph so far. Okay, any questions? Okay, let's check symmetry. F of -x. That's going to be x squared minus x, and that's going to be plus x. Because when you square -x, it's going to be x squared. Plug in a negative there, you get -x. Negative there, that's going to change the sign. Exact same. Nope. Exact opposite. Nope. So no symmetry. Okay, and now it gets a little bit interesting. Okay, let's talk about asymptotes. Okay, now, it has domain issues in between -1 and 0, but not at -1 and 0. So really, at this point, I could actually plug in -1. What do you get if you plug in a -1? You get 1 minus 1, so you get 0. Square root of 0 is 0. Then minus 1, so you get 1. So we've got this point of -1, 1. So there's another point on the graph, but nothing weird happens there. It just comes down and it terminates into that point. Just stops there. Wherever it was over here, it stops at -1, 1. And the same thing is true over here. Whatever it looks like over on the positive side, it just comes in and it locks right into 0, 0, and it stops there. So it's got a stopping point on this side, and it's got a stopping point on this side. The only interesting thing would be, as far as asymptotes go, what happens on the ends. So we want to find the limit as x approaches infinity of square root x squared plus x minus x. And we'll make kind of an informal argument here. Well, let's see. Yeah, I guess we ought to go through this. The other one we're going to check is what happens at the other end, at negative infinity. Oops, that's a minus. Oh, no. It is a plus. That's a plus, and that's a minus, right? So I was looking at the f of negative x. Okay, so if I plug in a really huge number, and then I add that and square it, and then I add a really huge number, and then take the square root. Does everybody agree this is going to get really big? And this is going to be subtracting something that's really big? So this is in indeterminate form, right? Can't apply L'Hopital's rule until it's a quotient, but we've seen problems like this before. Does anybody remember from chapter 2 what we did with these? And we used it once the other day. Let's see. That's not in the denominator, so you don't have a top and a bottom to balance that out. Let me change colors here.
Somehow power raised some.
Multiply by the conjugate. So let's do x squared plus x plus x. X squared plus x plus x. And so here's what we end up with on the top. You end up with x squared plus x minus x squared, and on the bottom you end up with the square root of x squared plus x plus x. These go away, so we'd be finding the limit as x approaches positive infinity. X over square root x squared plus x plus x. Okay, what is the top approach as x approaches infinity? Infinity. Go from one indeterminate form to another indeterminate form. You can then apply L'Hopital's rule. Now to make sure we get done with this, we're about out of time. If you apply L'Hopital's rule, you're going to find that the limit is equal to, nope, it's equal to 1. If you want to think of it this way, the top behaves like x, and the bottom behaves like, if you take a look at this, this is square root of x squared would behave like x also. Okay, that's just one rationale, but you can go ahead and apply L'Hopital's rule. You're going to get 1. That means on the right end, y equals 1 is our horizontal asymptote. This one's easier. Okay. Does everybody agree that if we square a huge negative number, we get a gigantic positive number? Then you're just going to subtract part of that number. Still going to be a big positive number. Everybody okay with that? Okay. So this part's going to go to positive infinity. What's this part going to approach when you plug in a huge negative number? Positive infinity. So this limit is positive infinity. So on the right, left end, we get that. Okay. That point is on the graph, and the point -1, 1 is on the graph. And we said on the left end it approaches positive infinity, so it must head up that direction. And on this end it approaches 1. Now, maybe it wiggles around in between, but most likely it's going to do something like this. Okay. This is just a very, very rough sketch of what that graph would look like using just precalculus. Yeah, we use some limits there. Okay, you could finish this by finding the first derivative, check and see where it equals 0. By the way, take a good look at that. Does it look like it would ever equal 0? No. What about concavity? If we started here and kind of curved like that, looks like this would always be concave down. You would want to check concavity over here because there would be a big difference between this and this. Okay, one would be cupped upward, one would be cupped downward. Okay, but we found first and second derivatives, done sign lines for those numerous times. That part you should be able to finish. Okay, any questions? Okay, is today Thursday? Holy cow. Okay. So you've got, on Monday, we're going to start 4.7. 4.7 is story problems that apply these ideas. So you've got to come up with the function. Generally speaking, they're a little bit easier functions, but you have to come up with them. That's what makes it difficult. So if you've asked your questions, if you've figured out most of this stuff by Monday, you're going to be in much better shape to do 4.7. Okay? So if you've got questions, please come see me.